Hi guys, 4Tutor here. Well, if you were in my math class, you should have known that I said I was going to film my presentation and put it on the 4Tutor YouTube channel. Well, I wasn't lying. I rarely lie about this stuff. So here it is. If you didn't see it, our presentation was about why the unit circle and how the unit circle took over trigonometry and how it's so important. It was created by me, obviously, Rags, who is a good friend of mine, I've known him since sixth grade, and Rohan F, who's a part of my team. Well, what is the unit circle? Putting it simply, which is realistically the only way I can put it, the unit circle is a circle centered at the origin with radius 1. You can't say much about it unless you're already an expert on trigonometry, in which case, why are you watching this video? It doesn't look flashy, certainly. It's just a circle with radius 1. However, in terms of trigonometry, it's so important. You can think of it like Welch's. They may not have enough value to give them to me because I'm not the best fan of Welch's, but if you give them to Hiran, they definitely have value. And Hiran is also one of my team members. He works on curriculum. Right. So here's the unit circle's impact on basic trigonometry, like tangent, sine, and cosine. The whole tangent is a slope thing comes from the unit circle, and I'll show an image to demonstrate. Let's just take this angle theta and give it a value of 45 degrees. If it's 45 degrees, that means this would be an isosceles right triangle. So x is going to be equal to y. Since the tangent is x over y, remember, x is the run and y is the rise. So it's actually, no, what am I saying? This needs to be y over x. Because it's opposite over adjacent. Since the tangent is just y over x, which is basically just rise over run, because y is the rise and x is the run. It's just x over x or y over y. In this case, it's 1 because it's 45 degrees. Sine and cosine can also be found here because you're theoretically, remember, sine and cosine are trig functions that include the hypotenuse. In this case, the hypotenuse is 1. If we take the opposite side, which you would use for sine, which would be this little guy right here, this would be y because here it's like a y above, and then this length would be x. So it's basically just y over 1 or x over 1. So that's why sine and cosine can be found here. Radians. Alright. Radians are an extremely important concept in trigonometry, and they also have the unit circle to thank. However, I doubt many of you guys, unless you're an expert on trigonometry, I doubt like many of you guys know what a radian is. I'll explain it and how the unit circle contributes to it. Put simply, it's a degree measure of the central angle when the radius of the circle, which is going to be 1 in this case, equals the length of its intercepted arc. I have an image right here. This was taken from an old McDougall Little Algebra 2 textbook I had lying around. It's actually a pretty good textbook, so I have link in the description. It equals the length of its intercepted arc. It's like, so remember, it's the measure of the angle. It's not the side measure. So basically, if this equals 1 and this equals 1, so that means you have this radian. Then it's 1 radian. 1 radian is 180 divided by pi, and there are 2 pi radians in a circle. For those who are like really weird and want to use decimals for some reason, it's 57.29577 degrees. Remember, radians are actually based on the unit circle. Alright, in trigonometry, instead of using degrees, which we don't even touch anymore, we use radians. Well, why? Well, radians are easier to work with the many different concepts trigonometry has. Outside of angle identities, which is the only place in complex trigonometry which you would use degrees, every other thing here uses radians. Trig graphs also have radians to thank, as their x-coordinates are done in radians. And they're measured in like pi over something, like pi, whatever. I'm not going to explain trig graphs right now. So, to conclude, trigonometry and trig graphs are based on radians, which again are heavily tied to the unit circle. You can't separate the two. Kind of like rags with tennis. The Pythagorean Identity. If you looked at the unit circle from earlier, which I put in my impacts on basic trigonometry slide, you would probably thought you could have found a right triangle. Congratulations! You just won $1 billion. Actually, no, I don't have enough money to give everyone who found that out. That's where the Pythagorean identity comes in. It's an extremely important trig identity. It's more important than all of those angle formulas, that's for sure. I mentioned that sine of theta when the radius is 1 is the y-coordinate, and cosine of theta is the x-coordinate. Again, right triangle. If the hypotenuse of the triangle is 1, the Pythagorean identity states that sine squared theta plus cosine squared theta equals 1. Because you're squaring the y-coordinate and you're squaring the x-coordinate and you get 1. Cosine squared theta means you're squaring the result of cosine of theta. You don't square the angle or some weird thing like that. So yeah, I guess the Pythagorean identity also is the unit circle to think. So in conclusion, the unit circle forms the basis of some of the most important trig identities and concepts. So if you're taking Algebra 2 trig anytime in the future, you should really learn this one, okay? The unit circle is so helpful. It's extremely powerful, and it's used in other circumstances, which I didn't put in here because I don't want to make this video too long. Well, I guess thank you for listening. And yes, I said I will be filming this and putting this on my YouTube channel. And yeah, so this is actually going to be my first trig video, which is not a derivation. So I'm probably going to put it in a new series called Why. It's essentially going to be me diving deep into how concepts are important in some ways or how useful they are. Thank you so much for watching, and I guess that's it for today. Bye bye.